Okay, let's start our lecture. So today we're going to talk about the architectural and the structural elements of various types of the buildings like residential, industrial, agricultural, public buildings, and so on. So our lecture will dedicate it to analyze and systematization the most common architectural and structural elements applied in different variations of the building. So according to the plan of our lecture, there will be review of the main architectural and the structural elements, which will include foundations, information about foundations, walls, columns, slabs, and so on. And the second and third, the control questions and literature. So let's start our lecture from the talking about the concept of foundations and the requirements for them. In general, the foundation is the bed. The foundation bed is the soil mass which located beneath the foundation. And so it's apply all the building loads and transfer it deeper in the strata, deep in the soil, right? So the foundation bed is so основание фундамент, foundation bed is properly selected by adequate prepared analysis. So entire structure will be reliable and stable. Classifications of the foundations can be divided into the natural foundations, естественные основания, and artificial foundations, искусственные. So natural, when in suit soils, so the soils located in the construction site, possess sufficient bearing capacity, so shows good sufficient and sufficient bearing capacity. Artificial foundation applied when the soil requires special preparations like compaction of the soil, strengthening of the soil, or just replacement due to insufficient strength or stability. There are basic requirements like adequate bearing capacity, absence of frost, having soils resistant to soil erosion under the influence or groundwater, and last, elimination of risk soil subsidence or landslides. So the in general, the quality of soil foundations defines the durability, safety, and making the soil selection and preparation with the right analysis, with the right with the right calculation and right design in general. Deformations. So the types of deformations is divided on the ground subsidence. So next one, the settlement, can be find the collapses. So this all changes of the ground is referred to the deformations actually. So it can be found when there are, for example, heavy buildings or loose ground soils, mm, when the soil volume increased actually by the water penetration, for example, and the horizon when the horizontal deformations is increased by the, for example, lateral displacement, the typical variants of um, typical variant of uh, structural soil stability. Right. So these deformations can be found on the various types of the building, and on the next slides will be show some examples of the this variant of the deformation actually. So the settlement. So settlement or ground processes which find in the ground actually is found due to the not enough compaction actually, which are find during the structural weight increased with the building erection, so during the construction. So and continues for some after the commissioning and stabilization is occurs. So the main factors of the settlement is soil properties actually. So moisture content, the collapsibility. Next one is the load magnitude, and the distribution scheme. So the load can be concentrated actually, uh, and uniform load actually. Next factor is hydrological conditions. It's again information about underground water level, the construction technology, for example, the schedule of the construction, consolidation effects, and so on. Next one we call like crane or tilt. So this is deformation, the special deformation, which characterized by the rotation of the foundation and the entire structure relative to horizontal axis. So the most typical for slender, narrow, and tall buildings actually, whereas there are minor deviations of foundation effect of overall stability. So there are two primary types of tilts. This is inclination, so means leaning. So there are also the name of one of the interesting building which are called like leaning tower. So leaning. The building tilts while the axis of its walls and columns remain vertically, and also twisting, torsion, so means. The most newest example is the given on this slide is the Tower of Pisa, so which located in Italy. It's starting inclining actually during the construction is begin due to the weak foundation soils. So this case clearly demonstrate us the importance of using of right applying the soil properties and preventing the differential deformations already in the calculation stage, in the design stage, right? So the till or crane is the hardest type of deformation that may be result of emergency state of the building. So the for the reason designers, architects must provide engineering solutions to eliminate this occurrence actually. Next, settlement. Settlement or is a specific type of foundation deformation associated with changes in soil structure, so under the external influence. So unlike the regular settlements which develops gradually, subsidence may occur suddenly and non-uniformly, making the particularly dangerous source subsidence or settlement actually. So the synonyms include compaction of collapsible soil, for instance, loose soil lose the strength when the raw water level is increased, for example. So it's resulting of considerable settlements. Compaction of permafrost soils, so during the sowing, which highly relevant in northern regions, for example, where the melting permafrost reduce soil bearing capacity. Next one is compaction of loose sandy soils, so under the vibrations. So under dynamic or seismic loads, such soils lose stability. So and the significant deformations can be found actually. So in general, the main hazards of subsidence or settlement lies in the suddenly find a large magnitude in the deformation of the soils. So that's very important to find the right way of choosing the type of bed of foundation and choosing the right type of the foundation itself actually. Next one slide is the information about foundations. So what does it mean foundation in generally? Foundation is the substructure substructure with located under the ground or for example under the water which receives all loads from the building and transfer them into the soil. So the reliability, stability, and all circle life or service life of the foundations depend on the correct choose and the proper construction of the foundation. So on the this slide, you can see the main types of the foundations which I used during the design of the building. The first one is slab foundation. So this is a solid reinforced concrete slab, so beneath the entire building. Сплитный фундамент, да? Strip foundation, ленточный. So this is a continuous reinforced concrete strap which located beneath the walls, actually load-bearing walls. It's one of the most popular type for low-story residential buildings. Pier foundations, pier foundation, or it's also called like column foundation. So this is a system of separately located piers or columns under the concentrated loads or light structures, for example. So mostly these types of foundations is applied for the production industrial buildings with the large spans between the main vertical constructions. And last one is the pile foundations, Swine fundament. So it composed of elements, piles, which are driven or drilled into the soil, and then it can be able to transfer load deeper, so deeper to the more hardened, more strong soils located in the stratum. So each type of these foundations has its specific advantages and also, of course, in some cases, disadvantages. Yes, and the places or areas of application. So the task of the architects and the designers is to know how to select the optimal type of according to the soil conditions, load characteristics, architectural requirements, and so on. So you should know the types and how to accept them according to the specific characteristics for buildings. There are special elements of foundations. So this picture illustrates the key of components and reference levels of foundations. First is the foundation cut-off level, foundation footing, foundation body, blind area, plinth, basement slab, horizontal waterproofing layer, and so on. So each of these components or elements of the building has its own requirements, has its own characteristics, location, some of them located in the top part of foundation, some of them in the ground part, so in the bottom of the walls, some of them near to the soils, and so on. So this slides illustrates the main loads acting on the foundation. So foundation operate under the complex load conditions. So and it should be able to accept all of them without any cracks and failures. So primarily loads includes vertical from the building. This means the own weight of the building or self weight of the building, equipment located inside the building, the weight of occupants of the building, snow, and other variants of imposed loads. Lateral loads, горизонтальные, да, боковые, lateral loads. For example, soil pressure, which acts from both sides of the foundation, which are located nearby to the foundation. Seismic forces is also one of the dangerous um, load for the building in general. Next one is wind. Also is the represents the lateral load. So, and in additional, the physical and chemical influences are also present. So, the soil temperature, salts, some special gases, biological factors, so microorganisms. If there are a higher water level, there can be found the humidity. So the higher humidity conditions. The dynamic loads is divided for vibrations from, for example, transports, in industrial equipments like cranes, which carry very heavy loads. And when they are moved, their stop is given the effect to the columns. That's also the type of the lateral load. Next slide is the information about requirements for the foundation. So a foundation is a critically important structural construction or component of the building, and the several main requirements is applied to it. The first one is strength, or it also can be called like durability. Yes, is very important actually for not only for foundation but um, for each type of the construction. Yes, because it should be it should be able to carry out all loads, all the weight of the buildings, and protect from the environment without any damages and then cracking. Next one is stability. So sustainability, actually, it must resist displacements, tilling, different settlements, and of course, if the building located in the seismic regions, is the seismic effects. Longevity or durability, right? So they must resist of or not resist actually. It should during the all service life of the building without it should stay all service life without any losing of the bearing capacity of the building. So resistance to impacts. The foundation must withstand the various type of impacts, like um, like 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 um, for example, again, moisture, biological influences, temperature, um, temperature, and so on. So cost effectiveness, effectiveness, yes. So the structural solutions must be rational. So providing the strength and reliability at the optimal cost. So very important thing. And the last one is the technological efficiency. So the foundation should avoid expensive operations and allow to use the modern building methods. So these requirements actually is not enough to only check the strengths, protection of environments, and so on. But if we'll say, we can say that this is the most important one. Okay, let's talk about the foundation types. So the main foundation types showed here actually divide into the maybe four main groups. In previous slides, we start talking about the types of the foundations, and here is given the some examples with the page with a photo of this foundation. First one is a strip foundation. I told you that the strip foundation is continuous reinforced concrete beam located beneath the bearing walls. Slab foundation is also reinforced concrete covering the whole building, so located under the whole building. So pile foundations, when we need to transfer the heavy loads of the building beneath the soil, so deep in the soil, when on the surface ground is loose soils, so not strong soils actually. That's in that case we need to use pile foundation and pile foundation. Yes. So the choosing of foundation again depends of the various things, and the most important is the type of the building, the constructional solutions, and architectural planning solutions. Um, Here is information in Russian. I will try to explain this in English. So the foundation by behavior. So the structural behavior of foundation are divided into two main groups. So a rigid foundation and the flexible foundation. So a rigid foundation designed primarily for compression, not for bending actually. So because built up a massive materials such stone, for example, from the reinforced concrete, and some cases masonry. So traditionally, it's used for low-story buildings and maybe heavy masonry construction. And the flexible foundation. So flexible foundation is capable of working under both compression, сжатие, and bending, растяжение. So this is modern reinforced concrete structures that which can resist complex of these two both schemes. Therefore, the choice between rigid or flexible foundations again depends on architectural design, the magnitude of loads, soil properties, the architectural and constructional solutions, and so on. So mostly it applies for multi-story constructions, and for various uh, stride structures like bridges, for example, and with long span for long span constructions. Here is some more information about the strip foundation. Here is pictures which illustrates the strip foundation. Mostly, strip foundation can be constructed by two methods. This is the first one is monolithic method, and next is prefabricated method. So we call it like precast. So precast method assembled on the factory. So from factory made blocks. So the speed up of construction requires the lifting machinery. So the first advantages is the speed, but the disadvantage is that it requires special lifting cranes. Monolithic, so also call it like cast in place with reinforcement, provide the highest strength, but requires in comparison with the precast one requires more time for curing. Curing means уход за бетоном. And masonry. Masonry built with natural stones or cast bricks. So cast bricks, or not cast bricks, factory bricks. I mean, when the bricks prepared in the factories. So the main advantages of strip foundation is a uniform load distribution along the wall. Yes, so it can accept the heavy external and internal loads from the bearing walls. The execution method. So how we construct it? Execution method. Strip foundations. The first one is the monolithic strip foundation. Is arranged on site by using the special formwork, опалубка, and the reinforcement, армирование. So they are cast with the concrete, rubble concrete, and rubble stone. So precast one in the right side of the slide consists of the factory made blocks, slabs, which are assembled with the cranes. Next one is the pier foundation. Pier foundation, or it's also called like the column foundation. So in various cases, it can be you can find the two names of this type of foundation. So the column foundation actually applied for lightweight buildings, for, like I told you previously, industrial buildings. It can be done by the various materials. Rubble stone, it's бутовый фундамент из камня натурального. Rubble concrete, buto-beton, when to the concrete is add the natural rubbles, natural stones. And the third one is the concrete, reinforced, next one concrete, and the timber. So the column foundations consist of beams and grillage. So I place it between the piers, and the beams is helped to tie the structures together between each other. So if we'll talk about some advantages, is economical efficiency of this type of the building. It's can be used on the strong soils, and it's one of the simple, so not so difficult variant of the foundation. Next one is the solid foundation and the slab foundation. So solid foundations accrue the entire building footprint. So it's transmit load eventually across the soil. So the slab foundation is the main example, actually. Mostly slab foundation construct with reinforced concrete. Also, it can be called like footing foundation. If it actually has one of the difficult thing, not difficult thing, or one of the disadvantages, according to the high material cost and the consumption of concrete and reinforcement. But of course there are and the places, so advantages. Yes, it can be used in the seismic regions. It can it shows the good schemes of transmission the load for the soft soils, for example, and it can resist to the differential settlements. So that's all I see. Next one is pile foundation. So pile foundation, zweinig fundament, used when the upper soil layers have insufficient bearing capacity, so they are very soft. And when the groundwater, for example, in Astana or St. Petersburg, the groundwater levels is very higher, and so the loads are transmitted through the piles, should be transmitted through the piles deeper, so more inside the earth. There are several types of the transfer mechanisms and bearing piles. It call it end bearing piles, забивные сваи, friction piles, висячие сваи. Also, there are variants of driven piles, shell piles, cast in place piles, bored piles, screw piles, and so on. So various types of piles actually accepted according to the right calculations, according to the soil conditions, and so on. Next slide shows us information about two main types of the piles. This is driven piles and cast in place piles. So driven piles is prefabricated elements, consist of reinforced concrete, steel or timber, which are installed with the hammers, for example, при помощи молотка, or by vibration equipment. То есть забивные, которые забивают, да, вглубь, cast in place, забивают вглубь. It can be made by the metal, can be made wooden, metal, or reinforced concrete. And the next one is cast in place or monolithic, which are directly prepared on the construction site. So there are a borehole, drill it or punch it, then there are installed reinforcement, and this pile is powered with the concrete. Special advantages for cast in place is that it can be used in the various places, but it needs driven actual equipment. Disadvantages, it's a cost, so it's a very expensive type of foundation, and also there requires higher number of the labor cost. So it means the number of workers who will prepare these piles on the construction site. Next one, cast in place layers. So it's again need to be drilled, the boreholes, then there are installed the reinforcement, and again it's concreted on the side. So the pile arrangement schemes or diagrams can be divided on single piles, a row of piles, so it's a multiply lines of continuous walls or beams, pile cluster, it's a ground pile under the column or a heavy loaded support. So and the last one is the pile field. So it's a large array covering entire the footprinting, so typical for multi-story buildings. Next one is the screw pile. We have actually a short time, so I will be some more quickly. So the screw piles. Here you will can find the information about the screw pile, and the last one is waterproofing. So waterproofing is the processes which are protect foundation against the water penetration and deterioration. So it's essentially for the durability of underground building parts. So there are special tanks preventing capillary moisture, protecting from the corrosion. Two types of waterproofing. It's a coating, not actually only two, several types of waterproofing: coating, membrane, spray applied, injection, and penetration. So that's all for today. Thank you for being with me. can find this lecture on my YouTube channel. Thank you very much. Bye. See you next time.